If you're watching this channel, then you have decided to change your life. And you have motivated yourself to set out on this most difficult quest to learn a programming language. You've convinced yourself that it will be good for your career and that it will look good on your resume. And you're prepared to invest your time to make that happen. But secretly, the real reason you decided to learn a programming language was so that you could make video games. Julia seems like a serious language for serious people. So you may be wondering, can I use Julia to make video games? Or will I need to learn yet another programming language? Well, let's find out. Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I am your host, the Dabbling Doggo.
I dabble.
In today's tutorial, we'll get an introduction to the GameZero.jl package, which is a relatively new Julia package, which was created to help beginners learn how to code using Julia by building simple 2D games. As of this recording, GameZero is on version 0.2.1, so it's still in the early stages of development. Unlike the Luxor package, which is quite mature and contains a lot of documentation, there's not a lot of information about GameZero since it's so new. But there is enough information available to get started. Plus, learning how to use GameZero will give you a taste of what it's like to use a package in its early days when it's still full of possibilities. By the end of today's tutorial, you'll know the fundamentals of game development and understand where GameZero fits in. You'll also know the basics of setting up a 2D graphics game environment and know how to interact with it using both your mouse and your keyboard. You'll also create your first video game. For this tutorial, knowledge of Julia and VS Code is required. Okay, let's get started. GameZero was created by Avik Sengupta, who is a vice president of engineering at Julia Computing. He's a well-known public face of Julia and can be seen in many YouTube videos on the Julia Programming Language YouTube channel. He presented a workshop at JuliaCon 2021 where he walks through the creation of a Flappy Bird clone using GameZero. A link to his workshop video is in the description below. Ahan Sengupta is the other developer of the GameZero package. He actually introduced GameZero to the world over a year ago at JuliaCon 2020. When it comes to game development in general, people tend to focus on something called game engines. According to Wikipedia, a game engine is a software framework primarily designed for the development of video games, and generally include relevant libraries and supporting programs. Game engines provide toolkits for the entire game development workflow and are typically used by the major commercial video game publishers since they allow for the rapid development of complex commercial products that are being developed by large teams. If you have ambitions of working in such an environment, then you definitely want to learn how to use one of the major game engines. Some examples of popular game engines include Unity, Unreal, and Godot. There doesn't appear to be an established definition for a game development framework, but in general, a game development framework is like a web development framework. In other words, a game development framework is a library or package written for a particular programming language that provides some basic tools so that the game developer doesn't need to create everything from scratch every time they want to create a new game. Some examples of game development frameworks are Pygame and PyGameZero. Pygame is a set of Python modules designed for writing video games, and PyGameZero is like Pygame, but it was created to be used in education to teach basic programming. Video games may be created using just about any programming language, but the most commonly used languages appear to be the low-level languages C# and C++. Unity is written in C#, while Unreal and Godot are written in C++. Again, if you're serious about becoming a professional game developer, then you'll want to add one of these low-level programming languages to your toolkit. When learning about game development, at some point you'll cross paths with something called SDL. SDL stands for Simple Direct Media Layer. SDL was originally created by Sam Lantinga using the C programming language, and it was initially released in 1998. According to Wikipedia, SDL is a cross-platform software development library designed to provide a hardware abstraction layer for computer multimedia hardware components. SDL manages video, audio, input devices, CD-ROM, threads, shared object loading, networking, and timers. Based on this Wikipedia description, you can see why this library would be of such interest to game developers, since it allows your code to interact with all of your computer's multimedia hardware. There's a Julia wrapper for SDL called SimpleDirectMediaLayer.jl. Game Zero is inspired by Pygame Zero and is built on top of SDL. In its current state, Game Zero is somewhere in between the SDL wrapper and a full-blown game development framework, with ambitions of becoming an educational game development framework similar to Pygame Zero. This means that it's the perfect time for us to get in on the ground floor by getting an introduction to this relatively new package with the expectation that not everything will work, and one should not expect the same level of documentation that one might find with a more mature package. With that said, let's fire up VS Code and learn how to use Game Zero. In your VS Code Explorer panel, create a new folder for this tutorial. In the tutorial folder, create a new file called rungame.jl. Also in the tutorial folder, create a new folder called mouse demo. Inside the mouse demo folder, create a new file called mousedemo.jl. Launch the Julia REPL by using Alt-J, then Alt-O. Maximize the terminal panel. Change the present working directory to your tutorial directory. Enter the package REPL by hitting the closing square bracket. Activate your tutorial directory. Add the Game Zero package as well as the colors package. Type in status to confirm the version numbers. Exit the package REPL by hitting backspace. Minimize the terminal panel. Okay, let's start using Game Zero. For our first project, we're going to set up a new game environment and then draw a circle in it. In your mousedemo.jl file, the first thing you want to do is to initialize your new game window. Interestingly, you do not need to compile any of the code in this file. You'll see in a few minutes that we'll be using the rungame.jl file to actually launch our game window. But you should get into the habit of saving your file as you enter in new code. You can use any named color from the colors.jl package, but you need to use this colorant syntax immediately followed by the named color in quotes. This code just sets the width, height, and background color for our game window. Next, we need to define objects that we want to use in our game. Game Zero calls these objects actors. Game 0 has the ability to create lines, circles, and rectangles. For the line constructor, the first two arguments are the x and y coordinates for the first point, and then the last two arguments are the x and y coordinates for the second point. In Game 0, the upper left corner of the game window is point 0, 0. Along the horizontal axis, numbers increase as you go to the right, and along the vertical axis, numbers increase as you go down. So in our game window, the bottom right corner is point 600, 600, and the center of the window is point 300, 300. For the circle constructor, the first two arguments are the x and y coordinates for the center of the circle, and the third argument is the radius of the circle. Now, we need to tell Game 0 to draw these actors by defining a draw method. On one hand, this code is self-explanatory. But on the other hand, this code does look unusual because you're defining a draw method while also using the draw function inside of it. This draw method is used by Game 0 to render on-screen objects and is automatically run every frame. That single argument g is called the game object. Let's take a look at what we've created so far. Save your mousedemo.jl file and switch to the rungame.jl file. Before executing this code, let's talk about a few things. In order to run a game in Game 0, you use the rungame function. Remember that our rungame.jl file is in a different directory, so we need to use the relative directory location for our game. Also recall that we did not compile any of our code for our game. The rungame function will take care of all of that for you. Also, this rungame.jl file is optional. You can enter this code directly into the REPL, but I'm using this file so I can save this code in my GitHub repository. Go ahead and execute this code. If all went well, you should see a blue circle sitting in the middle of an antique white square window with black lines intersecting it through the center. On my screen, it's a fairly large window, so I don't think it's displaying 600 pixels by 600 pixels. Game 0 may simply be displaying the game window at a larger size for some reason. In any event, it's a decent sized window on my screen, and you should consider the dimensions used within Game 0 as relative dimensions and not absolutes. At the moment, our circle doesn't do anything. If you mouse over it, or try clicking on it, or try using the arrow keys, nothing happens. That's because we need to provide instructions for that interaction. If you go back to VS Code, you'll notice that the REPL is stuck in an infinite loop, which is an indication that Game 0 is running in the background. You can break out of the loop by clicking in the REPL and just hitting Enter. Now, let's go back to our mousedemo.jl file and add some instructions that will allow our mouse to interact with our blue circle. The onMouseMove function lets Game 0 know what to do as your mouse cursor moves across the game window. The position input is the horizontal and vertical coordinates of your mouse cursor location in the form of a tuple. By using this code, you're telling Game 0 to place your blue circle at the same horizontal and vertical coordinates as your mouse. Save your file and go back to the rungame.jl file and try to re-execute the rungame function. it doesn't appear that anything has changed. That's because the game window that you're looking at is the old game window that's still open. Once you close that old window, a new window should appear. Now, if you place your mouse over the new window, the blue circle should follow your mouse cursor. To me, this is just incredible. This is real-time interaction with no delay. With this simple demonstration, I can imagine all sorts of uses for this. I'm recording my screen at 24 frames per second, which is a relatively low frame rate for gaming, so I'm not sure how it's going to look in the final YouTube video. But you'll have to trust me that the blue circle is following my mouse smoothly on my screen without showing any delays. Now, just to spice things up a bit, I'm going to show you how you can add text to your game window and have Game Zero updated in real time. Before you can add text in Game Zero, you need to find a font file to use since Game Zero will not go into your operating system's font directory automatically. Game Zero is expecting a folder called Fonts and expecting any font file you want to use in your game to be inside that folder. So, back in VS Code, let's go ahead and set up a fonts folder inside our mouse demo folder. Now, go to the directory location for your system's fonts. I'm using Windows, so my fonts are located on my hard drive in the fonts folder inside the Windows folder. You can select any font that you like and copy that font file and paste it inside the fonts folder that you just created. I'm going with Comic Sans MS Bold. In the Windows File Explorer, you should see a file with a .ttf file extension. If you click on it, you should see a preview of your font in different font sizes. Now, go back to your mouse demo.jl file in VS Code. Inside your draw method definition, add a few more lines of code to have Game Zero draw some text in your game window. In order to create text, use the text actor method. The font name and font size are self-explanatory, but the color keyword argument is different. Rather than using the color's colorant syntax that we use for the shapes, you need to enter in the color for the text as an array of integers from 0 to 255 for the red, green, blue, and alpha channels. As far as I can tell, the RGB settings work just fine, but I don't think the alpha channel is working here. A value of 000255 is the setting for the color black. In the colors.jl package, they provide a list of all of the named colors, but they provide RGB values from 0 to 1 rather than 0 to 255. So just be sure that you make the appropriate conversions into integers between 0 and 255. Now save the mouse demo.jl file. Click in the REPL and hit enter to break out of the loop, and then close your old game window. Go back to your run-game.jl file and rerun the run-game function. Now, when you move your mouse cursor across the game window, the X and Y coordinates should update in real time as you move your mouse. Pretty amazing, right? For some reason, I can only go from 0 to 599. I can't seem to get it to read 600. try centering your mouse on point 300, 300 to see how precise your mouse is. For me, it's not very easy, but let me know if you have better luck. Okay, so that does it for our mouse demonstration. Now, let's learn how to interact with our game using our keyboard. Click in the REPL and hit Enter to break out of the game loop. And then close your game window. The reason why I'm being so prescriptive about telling you to break out of the loop by clicking in the REPL and then hitting Enter is because I found that if you try to break out of the loop by closing the game window directly, or by using Ctrl-C to abort the loop, Game Zero doesn't like that, so you'll need to restart your Julia session for some reason. But breaking out of the loop by clicking the REPL and hitting Enter seems to work just fine. Now, back to the show. For this section, keep all of your files open. In your tutorial folder, create a new folder called Keyboard Demo. Inside the Keyboard Demo folder, create a new file called keyboarddemo.jl. For this keyboard demo, let's start by copying and pasting the code for the mouse demo, with the exception of the code for the mouse instructions. Now delete rows 19 through 23 for the text. Okay, now let's add some instructions to handle keyboard inputs so that we can use the arrow keys to move our blue circle rather than using the mouse. The onKeyDown function is similar to the onMouseMove function. Remember, on the vertical axis, numbers increase as you go down. This code may be a little confusing since I've decided to keep the name mouse for our blue circle actor. The blue circle called mouse should not be confused with your actual hardware device. Be sure to save your file, and then let's take a look at what this code does for us. Go to the run-game.jl file and comment out the run game line for the mouse demo. And add a new line to run the keyboard demo and then execute that code. You should see the exact same game window that we used before, but if you move your mouse over it, nothing should happen. Now, try using your arrow keys. The circle is definitely moving, but it's really slow. Even if you press and hold an arrow key, it's still really slow. Let's try changing the values in our code to see if we can get our circle to move a little faster. So now, every time we press an arrow key, our circle should move by 10 units rather than 1 unit. Save your file and let's see if changing that value from 1 to 10 helps. Okay, so that's better. But now, we notice a new problem. Our circle can move off the screen. Sometimes it's useful to have actors that can move in and out of your game window, so it's good to know that it's possible to do using Game Zero. But for this demonstration, let's contain our circle inside of our game window. For this version, we added ternary operators to check to see if our circle is located at any of the 4 window borders. As you can see, the circle actor called mouse has attributes that come included with Game 0, which identifies the top, bottom, left, and right edges. This code is telling Game 0 that if the circle is at a window border, don't let it go any further. Save your file, and let's take a look to see if this works. I know that you can't see my keyboard, but trust me, I'm trying to move the circle out of the game window, and Game 0 is not letting me, so our code works. Okay, so that does it for our keyboard demo. Now that we know some of the basics, let's try to make a simple game. In this section, we're going to create a simple game called Cheese Run. The actors in this game are a mouse that we control and a block of cheese at the end of a maze. The objective is for our mouse to reach the block of cheese in the fewest number of steps. Let's start by getting out of our loop and then closing the old game window. In your tutorial directory, create a new folder called Cheese Run. Inside the Cheese Run folder, create a new file called cheeserun.jl. Also inside the Cheese Run folder, create a folder called Fonts. And then copy and paste your font file from the mouse demo example into your new fonts folder. As stated earlier, Game 0 is expecting a specific file structure for your game, so you will need to add your fonts folder and font files for any new game. The Cheese Run game window will be the exact same window that we've been using throughout this tutorial, so you can just copy and paste it from one of the other demo files. Now, we're going to introduce something new. I can't find any documentation on this, but I found this code being used in the tic-tac-toe game example provided by Game 0. It appears to be some type of flag letting Game 0 know the state of gameplay. As long as this flag is set to true, the game will continue. Once this flag is switched to false, Game 0 will stop running the game, but will not break out of its loop. So it appears to be some kind of holding pattern for your game. Next, we want to set up our actors. As you can see, most of our actors are just basic shapes. For the rectangle constructor, the first 2 arguments are the horizontal and vertical coordinates for the upper left corner of the rectangle. And the last 2 arguments are the width and the height, respectively. For the score, I'm setting the initial value at 1000. The player will lose a point every time they take a step, so the way to get the highest score is by taking the fewest steps. Next, we need to tell Game 0 to draw our actors. This is where things get a little messy. The first few rows should look familiar, since it's just drawing basic shapes. The if-else conditional is being used to determine what text to print on the screen. While the player is moving the mouse actor around the game window, a score counter will display in the upper left corner of the game window. Once the player gets to the block of cheese, the text will change to display the final score. The collide method in Game 0 checks to see if two actors are touching on the screen, and then it returns a Boolean true or false. So in this case, once the mouse collides with a block of cheese, the game will end and the final score will be displayed. Finally, we need to define the keyboard inputs. This is by far the messiest part of the code. I'm going to enter this code in first, and then provide some explanations afterwards. I know that this code is difficult to see on the screen, but you can find all of the code for this tutorial in my GitHub repository. This code will allow a player to move the mouse actor around the game window by using the arrow keys on their keyboard. The conditional statements are checking to see if the mouse actor is colliding with either a maze wall or one of the game window borders. At the same time, it's deducting 1 point from the score every time the player hits an arrow key, even if the player is colliding into a wall. I have to admit that I am not proud of this code. It doesn't look very elegant to me, and I'm sure there's a better way of doing this. This code does work, but it's very hacky to be sure. Let me know if any of you come up with a better solution. For now, save your file and let's take a look at what we just created. Go to the run-game.jl file and comment out the line for the keyboard demo. And add a line to run the cheese run game. If you're seeing what I'm seeing, then congratulations! You have made your first video game using Julia. It doesn't look like much, but let's play the game and see what happens. So that's the score to beat. Let me know your high score in the comments below. That was fun, right? And now you possess the power to create your own video games. Let me know what clever games you guys come up with in the comments below. Well, that's all for today. If you made it this far, congratulations! So we really only covered the fundamentals today, so it's too early to draw any conclusions about Game Zero after just one tutorial. But I think it's safe to say that if you have ambitions of becoming a professional game developer, then Game Zero is not the right tool for you, at least not yet. At the moment, Game Zero is like an easier to use version of SDL, with some tools to make it easier to create games. Since it's basically an interactive multimedia sandbox, Game Zero has the potential to be used for so much more than just making video games. So if that type of raw, experimental lab environment appeals to you, then you should definitely check out Game Zero. Personally, I like it, and there's still a lot of material to cover. I'll be making another Game Zero tutorial for next week, so stay tuned for that. Before leaving for today, please be sure to go to the GitHub page for GameZero.jl and leave a star. If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julia tutorials, please be sure to subscribe and hit that bell. If you like what I do, then please consider joining and becoming a channel member. New tutorials are posted on Sundays/Mondays. Thanks for watching, and I'll see you in the next video.